So good afternoon all. Am I audible? See, one information I need to inform to you, and that is don't do the student registration process um, this month. Okay, why? Because some administration process has to be done after your registration, and that has to be completed by end of this month. So which is not possible because uh, next 2 days weekend is coming, and then Wednesday holiday is coming. So it will be difficult for us to process everyone's registration. Not everyone will do their registration within 2 or 3 days. So what we have discussed and finalized is from next month starting, from day one of you know September, you start the registration. Okay, don't do the registration before that. If you have done the registration now, okay, if you have completed means no issue. We will reject your registration from our side. You can do the registration once again after no one. Okay, is it clear for all? So please don't do it before. Even if you are doing also, we will try to reject you. Okay, because since we have to do some process. Okay. So that's why I've removed the message from the group also. So I will again post the message so that you can do the registration at that time. Okay. Okay, let us go into the class. Okay, so before going to the class, how many of you like Titanic movie and how many of you like probability? So put it in the chat. Okay, so in today's session, we are going to see about something which is related to the Titanic and then uh, probability related algorithm. So which is nothing but Titanic survival prediction, and the algorithm which we are going to see is known as Navy BIOS algorithm. Okay, so let us. Okay, so in this data set, what we are going to find is we will be having some data of whoever has traveled in the Titanic. Okay, and then based on some parameters, we are going to find whether someone with this similar criteria will survive in this Titanic chaos or not. Okay, that is what we are going to predict. So what are all the datas we are collected from those passengers are their age and then passenger class, which class they have traveled, and then their sex and then fare, how much fare they paid for that Titanic. Okay, based on that, we are going to predict whether the person might have survived or not. Okay, so again, it is like a yes or no question. So we can say it is a classification type of problem. Okay, then we know the loading and summarizing the data set, right? So here also I'm going to use the available data set in the CSV format. So I will use the pandas to import the data set, and then I will find the shape and some rows and columns of our data set by using the dataset.yet method. Okay, let me show you the data set also. So this is how the data set will look like. The passengers class, which class they have traveled and what is their sex, and then their age, fare, and then whether they have survived or not. 0 means they have not survived, 1 means they have survived. Okay, and if you see means uh, first column, do we need the passenger class or not? Yes, we need. Why? Because mostly whoever has traveled in the first or second class, they had more probability of survival because they escaped from the ship first. Okay, so we can take that first column, and if you see the sixth column, uh, when comparing to the other columns, it is having in a categorical format, right? So we all know that how we can perform the mapping. So by using the mapping method, we can convert all male to 0 and female to 1, or vice versa. Any one pattern you can take. So this column we need to pre-processing we have to do, right? Then if you see the age column means some columns are missing. See, sorry, some values are missing in this age column, right? When compared to other columns. So this is the first data which we are seeing with the missing values, which is nothing but the NaN values, right? So that also we are going to see how we can handle these missing data. So previously we have done, right? Uh, how to handle the missing data. So either we can use the mean value or median value or the mode value, right? Since it is an age, we can go for an average, which is nothing but a mean value also we can fill in this area wherever missing values is there. So that also we will be seeing here. Okay. So as I told, we will be using the mapping gender text data to binary numbers. Okay, so we are going to map male as 1 and female as 0. Okay, then we will segregate the data set into two. So we can say x-axis, sorry, x variable. If you don't want, we don't need the survived data in the x-axis, right? Because x is going to be our input part. Okay, I have showed like dataset dot drop new syntax like that I have given. Okay, instead of using the same like colon minus one, we have used the another method called dataset dot drop. In that I'm dropping the column name called survived. Okay, and the axis I'm specifying it as columns. And then in my y, I'm storing the dataset dot survived. Okay, those details alone I'm storing. Then I have to perform the train test splitting method, right? So in that I will pass the x and y. Okay, and I will put 25 percentage for testing and remaining 75 percentage for training. So those and all common steps only, right? No any change in that. Only data pre-processing as a first step. We are converting the male to 1, female to 0. As a second step, we need to deal with the missing data. The NaN values, we have to replace it with some other values. So for that, first, to find what are all the NaN values is there, we can give like x dot is Na. Okay, dot any. So any column is having this NaN value, we are going to find. Once we have found, we can replace it by using the method called fill Na. Okay, so I will specify with fill Na and then x dot age dot mean. So mean of ages I will take and I will fill all the NaN values with that value. Okay, then so as I told, we are going to see the algorithm, which is nothing but the Navy BIOS algorithm. So why I told do you like probability or not is because this Navy BIOS algorithm is based on the probability which you have learned in the school times, school or college times. So similar type of algorithm only. Okay, so Navy BIOS algorithm is not just a single algorithm, it is also called as a family of algorithm. So based on the probability, it will find the classification. Okay, so let us see in detail. So bias theorem, what is the bias theorem? The probability of an event occurring given the probability of another event that has already occurred. Okay, in Navy bias, what they will do is all the events which are occurring are independent to each other. Okay, that is what it meant. So here, let us see one example to understand it even more better. Okay, assume that you are playing a card game. Okay, if you don't know about the card game means in that you will be having four shape card. Okay, like diamond, four shape. I'm not sure about all the shapes because I don't play cards, but four shapes will be there, and in each shape we will be having 13 cards. Okay, so totally we will have 52 cards. In that, my our problem is I have picked one diamond card. Okay, I need to find the probability of that card is queen. Okay, so I want to know what is the probability of getting a queen diamond card. Okay, that is my question. So what and all things I need to do is first I will find the probability of finding queen in total cards. So I have told total number of cards is 53, and I told we will have four set of cards. So each set will have 13 like 2 to 10 will be there. One instead of one we will have ace, and then we will have king, queen, and jack. Okay, so four set we will be there. So four set means four possibility of getting a queen, right? So 4 divided by 52, which is nothing but 1 by 13 probability is there. So out of 13 card, there is one possibility of getting one queen card. Okay, here queen in total cards only we are checking, not in the diamond part. Okay, so first step. In the second step, probability of finding the diamonds from total cards. So what is the probability of finding diamonds from the total cards? Totally 52. And how many diamond cards will be there? 13. Correct. So 13 divided by 52, which is 1 by 4 possibilities there of getting a diamond card. Then in the third step, we are going to find the probability of finding a diamond in a queen. Okay, I have taken 13 diamond cards. Okay, what is the probability of getting one queen in that 13 cards? Obviously, it is going to be one probability, right? Because in each set we will have only one queen. So 1 by, okay, sorry, probability of finding diamond in a queen. uh, So totally we are having four queens, right? In four shapes we will have four queens. In that there is only one possibility of having a diamond queen, right? This I told by mistake. So hope you might have understood what I tried to say. In the fourth, this part alone I will re-explain again. See, I'm asking probability of finding a diamond in a queen. So totally we are having four set. In that four set, four queens will be there. In that only one queen is going to be the diamond queen, right? That is what here mentioned as 1 by 4. Okay, so we need to find, right? So what is the solution of finding the question? For the question I have what I have asked, I am picking a diamond card. So what is the probability of getting a queen in that card? Okay, so this is going to be the formula. So P of diamond by queen into P of queen divided by P of diamond. So that is what we found it here. So P of diamond by queen means 1 by 4 into P of queen means 1 by 13 divided by P of diamond, which is 1 by 4. So if I do all the process means I will get the output as 1 by 13. So 1 by 13 possibility is there of getting a, diamond queen card. Okay, hope it will be clear for you all this example. Okay, so every pair of a featured being classified as independent. That is what I told. Every classification is considered as a independent to each other and having equal contribution. Okay. Then, as I told, this Navy Bayes algorithm is not a single algorithm, it is a family of algorithm. So these are all the algorithms available in the, Bayes theorem. Okay, in that we will be seeing about the first and main algorithm, which is nothing but uh, Gaussian naive Bayes algorithm. Okay, and we are also having a multinomial and complement, Brownlee, and then categorical naive Bayes. So in that we will be using only the Gaussian naive Bayes algorithm. Okay, so how this works is the parameters are estimated using the maximum likelihood. Okay, we will say likelihood, probability of occurring that event. Okay. Mm. So as we all know that there is some advantage of using as well as the disadvantage. So first of all, advantage means it is very easy and fast to predict the class of a test data set. And for multi-class prediction, we will go for this Navy Bayes algorithm. So multi-class prediction means what we have seen in the previous class. Like we have seen only the digit recognition only, right? We have not seen any other multi-class. So if you are performing any multi-class prediction means this Navy Bayes algorithm will be useful for you. And another advantage is when assuming of independence hold, a navy Bayes classifier perform better compared to other models like logistic regression, and you don't need, I mean, you need only less training data. Okay, so we don't need to give more training for this particular algorithm, so it will work better than the logistic regression if you are having an proper independent variables. Okay, and disadvantage is this, what we are calling it as an advantage that can also become a disadvantage, whereas all the time in the real time scenario, all the time we may not be able to get variables with a completely independent to each other. So those scenarios, our naive Bayes may be performing poor when compared to other algorithms. Okay, if it is a categorical variable as a category in the test data set. Okay, this is also one scenario. In the category data set, when we are giving some training, okay, training term we have trained with only few set of cards only. Okay, but at the time of testing, I have given some new category which doesn't have in this classes means it will return a zero probability. Okay, so this is also known as zero frequency error. Okay, the example which we can give in this case, the card case also, if you have seen means I have considered for only 52 cards. Okay, because 13 set for I mean 4 set, each set 13 card I have told. But in the same card we will be having one joker also, right? Whether I don't know joker is included or excluded in the card. Suppose assume that you have not trained the joker card during the time of training. Okay, and then you are passing some joker card means it cannot able to recognize as a class. So that time our model will get failed. Okay, when new class or new any direction is happening, that time what it will return is it will return as zero probability of occurrence, but in real time it is occurred, right? At least once it has occurred, so that error will be occurring. Okay, and the another limitation is, as I told, it will assume everything as an independent predictor. Okay, but in real life it is almost impossible that we get a set of predictors which are completely independent. One will be dependent to each other, right? Maybe not all the variables will be independent to each other. Okay, so that is will become an disadvantage for this navy Bayes algorithm. Then, where and all in real-time application they are using this type of naive Bayes algorithm. First, text classification. Okay, for text classification we can use example is Grammarly is there. Okay, in that based on your text it is giving some emoji, right? So it is classifying whether it is encouraging or motivating something, it is categorizing, right? So that we can say it as one example. And then spam filtering. So whether this mail is a spam mail or not, based on the keywords it is filtering, right? So that we can say spam filtering, sentiment analysis. Okay, in Twitter and all, Twitter, Facebook and all, if you are typing something means your account can be blocked, like that they are saying, right? So there we can use. So text is classification is similar to sentiment analysis also, we can say. Then recommendation system is there. Then multi-class prediction also possible by using this Navy Bayes algorithm. Okay. Then remaining steps and all common for you all only. So training, we will be giving model.fit. We will train with X and Y train values, and then we will validate by using the accuracy score. And finally, we will predict with some new values. So new person's detail. What are the details I will pass? I will pass which class the person has traveled, what is their age, and what is the sex, and what is the fare they have paid. Okay, so based on that, it will say whether they have surveyed or not. Okay, so let us directly go into the program part. Hope it is clear for you all this algorithm and this concept. Very simple concept only. So Titanic dataset we are taking. So as a pre-processing, we are converting male to 0, female to 1, and then we are filling the missing data of ages with the mean of age, and then we will pass the data set into our algorithm. Later on, we will predict by passing some new values, and we will ask whether this person will survive or not. Okay. So let me import the data. So whichever steps we are doing immediately, I mean frequently, that I will do it a little bit faster. So remaining we can do it one by one. So as a first step, I'm importing the libraries. So I'm having the data set Titanic survival.csv. So I'm just loading it. Okay, so I have loaded the data set, then summarizing the data set. So totally we are having 891 passengers details with 5 column information. Okay, then so we have to map the text data to binary value. Okay, so what I'm going to do is so let me take the data set of, so that column details alone I'm just taking the same syntax we have already seen. So dot map, we will give the value which is present as a key, and then new value as value in the dictionary format, right? So female I'm giving it as 0, male I'm giving it as 1. Okay, so to save it as an integer itself, so I will convert it into as type as integer. Okay, so now after performing that, if I print the data set head, so my sex has been converted to ones and zeros, which is the binary value. Okay, and the next step is segregating them into x and y. So previously, whatever command we have used, instead of using that, I'm going to use the different syntax. So last column alone I don't need, right? So I can drop that last column and I can pass it to my new variable. Okay, so this drop will not going to affect my original data set. It is going to pass one new data set only, so no problem. Okay, so data set dot drop. So survived, that column alone I don't need. The axis I have to specify it as columns. So this is my x value. Okay. So similarly, I have to perform for the y value also. Okay. So to make it easier, what I can do? Simply I can give dataset dot survived, which is my column name. That's all. So these are my y values. Then as a next step, what I have to do? I have to find and remove all the NA values from our features y. Okay. So simply you have to give x dot columns. Okay, so this will return what are all the columns are having the NA values. This NA. Okay, any. If I give any means any column if having means it will read X not defined. Okay, here I have to give capital X. Sorry. See, the index age is having the missing values. So to fill that, as I told, we will be using the fill NA method. And what value we are going to fill? The average age of the remaining ages present in our particular column. Okay, so to do that, so x dot age I'm taking is equal to age dot fill NA. So inside that x dot age dot mean. Okay, so now if you check means you will not have any missing values. All the missing values will be filled. Okay, then if I go and check rerun this particular line, okay, it should not return me any column name. Correct. See, it is empty. So all the empty variables has been filled. Then, okay, this I have checked it here itself. Then I have to split the data set into train and test part. So this also like from sklearn dot model selection, we will be taking the train test split values. So x, y, and then test size 0.25, random state 0. Okay, then do I need to do feature scaling or not? So what are all the columns we are having? We are having passenger classes there. So that will be very less values, right? One, two, three. Very less passenger classes are there. and remaining if you see means age is there, that will be in different unit. Fare, that will be of floating point, some values will be there. So we are not having a common units for these three columns, right? So it is better to perform a feature scaling. Why no need? Age is in will be in, it is age and fare is similar like age and salary, right? Both are not in same unit. So we can go for a feature scaling to standardize. Otherwise, the class will get less priority, right? Because it is having only 1, 2, and 3. Sex is like 0 and 1, so no problem. Age will be differ, fare will be also different fare, right? See here 22 is there, 71 fare is there. So lot of difference are there. Okay. So that is why we can go, sorry, we can go for the feature scaling. Okay. So feature scaling also we have already done pre-processing. So from that import standard scalar method. Okay. So why I'm using the same syntax most of the time is so that you can easily remember. Each time I'm changing means it will be harder for you also. So fit transform and transform. So this is also common. So extrain and then next test. Okay. Then next step is training part. So here only small changes going to be there. From which class I'm going to take and which algorithm I'm going to take. Okay, so this, since it is a navy bias algorithm, completely a new algorithm, so you will be taking it from sklearn dot navy bias. Okay, that class name itself navy bias. From that you are going to import the Gaussian NB. Okay, short form. So GNB will be caps Gaussian NB. Okay, navy bias in short it is showing like NB. So for that I am going to train the model. Okay, I'm not going to pass any parameters for this. So it will be all of default parameters. Okay, so for this model, I'm going to fit the datas. So X train value and then Y train value. Okay, so Gaussian training also over. So before predicting whether the person will survive or not, first we will test our model and then we will check for the accuracy of our model. Then later on we will go, okay, otherwise I will put it as last step. Once the accuracy has been tested, then we can predict whether the person will survive or not for a new data values. Okay, so for y predict is equal to model dot then y predict. Okay, so this is the y predict value. Let us see the accuracy, how much accurate it is matching with the actual value and the predicted value. Okay, so for this also we are going to find only the accuracy score. So simply sklearn dot matrix. Okay. Then print white test or predict. Okay. So from okay, I should have multiplied it with 100. Sorry. So we are getting 77.5 percentage accuracy for this model. Okay. So let us see. Some new values also we will try to pass, and then we will see whether it can able to say whether it can the person will survive for the given data or not. Okay, so this is also a basic Python code only. We are going to get input from the user, and we are going to pass the data to our model, and then whether it is predicting one means we will say the person will survive. If the person is no, I mean, otherwise we will say the person will not survive. Right? So, so enter person class, passenger class, not person class, passenger class, class number, and then the gender or sex you can say sex. So here, if I simply say gender or sex, if I'm saying means they may enter like male or female, right? So to avoid the confusion, so we can simply ask them to fill like this. So 0 means female, 1 means male. Okay, just for our understanding. Okay, then age. So that also we can get it in the int format. So int of input of enter age, and then what we have to combine all the information into one set, right? So equal to, so what our class I have here? Play class, like age. Okay, okay. I forgot the far, right? Far also one of the parameter, right? So far. So this I can get it as a float value also, right? Far doesn't need to be a integer. So int of enter far. Okay. Then we have to pass this person into my result. Predicted model. So model dot predict the person. So if the result is equal to 1, then we will say the person will survive. Might be survived also we can say because it has happened in the past, right? Survived. Else person might not be survived. Okay. So let us give some information and we can check whether they have survived or not. So what are all the information we can, okay, I'm saying the person has traveled in the second class. Okay, and the person is male. Age is 28. Fare, yes, paid. I don't know the exact fare, so I'm just giving 80. Okay, what error I have done? Value error. X has three features, but we're expecting four features as in four features. What are they? Passenger class 6, age and fare. Okay, did I haven't passed? Okay, sorry. Here I have made the mistake. I have only given P class 6 age, but I forgot to add the fare. Let me add that too. Okay, now if I do the same thing, like I'm just giving same second class male, his age is 29 now, fare is 85. Okay, okay. Luckily, the person might have been survived, right? So whether you are able to understand the program, what I have done, do you have any queries? Okay, no any queries? So shall I wind up the session then? Sir, when to do future scaling that part alone once again? See, simple. So many columns you are taking. Okay. And all the columns, mostly we will be passing the values in the numeric format only to the machine learning. But some scaling is there, right? For age means the maximum how much age you will be passing. 70, 80, touching 100 and all very rare only, right? But when you go for a salary or here in the case fair and all, if you take means minimum itself, assumption I'm taking, minimum itself 100 may be there, right? Salary means 10,000 will be there. So can you able to compare the range? This is starting from like 18 to age will be like 18 to 90. Whereas salary will starting itself 10,000 to 1 lakh will be there. Fare means again minimum fare if you go also like 50 rupees also will be there, right? And maximum it can be 1,000 or more than that. So the scaling is very different, right? So we cannot compare it in a single scale. So to make it easier only for the machine learning, in today's case, if we take means passengers class, passenger classes only three classes are there. So what our algorithm will do is it will give more priority. If you are not doing the feature scaling means it will give more priority to bigger numbers. Okay, because machines knows only the number. It doesn't know it is a salary. Okay, it is a age or a class or anything. Okay, so that is why we are doing the feature scaling. When we will not go for a feature scaling from the beginning, if you have seen means only for hours and the sleeping hours. Both are in the hour case only, right? So that is where we didn't do the feature scaling. In the remaining places and all, we often do the feature scaling. If you are using only one column as your input variable, that time you don't need to do any feature scaling. That's the difference. Okay, clear. Okay, super. So once again, I'm saying do the student registration portal after 1st of September only. Okay. So whoever has already done, if any of your friends done or anything means, uh, we will be rejecting that. So you will be getting a mail in case you have done, and if you are getting a rejection mail means don't get worry. You can again re-register afterwards. Okay. I think some people are doing parallelly. I need to call them and inform them also. So I'm winding up the session for today. So any doubt means you can ping me. Okay. Thank you all.